Okay, welcome to this video on the 2019 Section B, Question 6 of Higher Level Technical Graphics on the ellipse and the parabola. So the curve ABC is a parabola with vertex at B. The curve DEF is an identical portion of the same parabola at vertex E. So that's the translation there, a bit of question 5 transformation geometry involved in it. The curve JKLM is an ellipse with focal points at N and P. Line BT is a tangent to the ellipse at point T. Draw a design showing clearly all constructions and points of contact. Right, so I'm going to start here with the parabola ABC. So the width of half of the parabola is 80 and the distance from A to B is 40. So I'm going to use the rectangle method to construct this, right? So I'm going to mark 80 along the bottom for the half on the left hand side and further 80 on the right hand side for the right hand side of the parabola. The altitude is 40, so I'm going to mark up 40. Now I'm going to mark points at every 10 millimeters going up, because at the rectangle side, the rectangle method rather, you have to divide one side of the rectangle up into equal divisions and then the bottom edge of the rectangle up into the same number of equal divisions. So along the bottom I'm going to mark every 20, because 80 divided by 4 is 20, and then I can do the same on the right hand side. Okay, so I've then marked along the bottom. Now I'm going to draw vertical lines up. So a little bit inaccurate, that one. Okay, so this is the vertex B and this is A. So these points here at point A, these points going up along the side, so I'm going to join all them to the vertex. So you can see I've joined them to the vertex. Now I'll do the same then the other side. You could mirror you could do one side, i.e. the left hand side of the parabola, and mirror it just over to the right if you wanted it, but it makes no odds. So I'm going to do the same here. So these are the points on the parabola. So I'll label these 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. So where 1 touches 1 is a point in the parabola, where 2 touches 2 is a point in the parabola, 3 touches 3 is a point in the parabola. And we're going to freehand sketch these in. So you're keeping your hand inside the curve, you can freehand sketch these in. Now I'm just going to pause the video and do the other half, so I can spin the desk around to keep my hand inside the curve. Okay, so we'll go back at it here. Now there we have ABC done. Parabola ABC. Now the next one it says is parabola BEF is an identical portion with its vertex E, which is 20 millimeters below it. Alright, so this is the new vertex E. So this is a translation. So we're going to extend the lines down from all the points on the parabola. We're going to set our compass to 20 and we're going to mark them down. And then I just forgot to do that last one, so just bring it down. Okay, we're going to do the same thing again. We're going to freehand sketch those points in. We're going to connect them together. So keeping the hand inside the curve. Okay, and we don't need to worry about what's below this line here, so I'm just going to heavy this in, and then we can heavy this segment along here. Now if you don't have it going below the baseline, an outline of the curve, you're asking to lose marks, because how else can you judge it accurately? Okay, so that's that part done. Now we're going to deal with the ellipse. Alright, so J is one of the vertices. It's up 30 from the vertex of the parabola, and it goes off at a 60-degree line. The length of the major axis is going to be 170, and the distance between the distance from the major or the minor axis to each focal point is 70, so that means the distance between J and N is 1585 minus 70, and L and P is 1585 minus 70. So I'm going to establish the points J, L, N and P. What we do not know is points K and M. We are not given the minor axis, or the minor diameter rather. So I'm going to go up 30 here. Heavy this line in. So line J to L is a 60-degree line, 60 degrees. So I'm going to draw my line at 60 degrees here. And I'm going to mark 170 along that line. Okay, and I'm going to measure up 85 for the center, in 15 there for that focal point, point N, and then 155 from this point J is the second focal point. Okay, or 15 millimeters back from 17 centimeters, so 155 millimeters. So there's P, F2, there's L, okay, this is N, and this is J. So the minor axis is going to be at a 30-degree angle, because it's going to make a right angle with the major axis. Okay, and we are unaware at the moment of the minor diameter. But what I can tell you is, okay, the distance from N to K plus K to P is equal to the major diameter. So that must mean, if K is in the middle, it must mean that N to K like that is equal to half the major diameter. So I'm going to set my compass to half the major diameter, and I'm going to swing from N. Where it intersects the minor axis is a point on the minor diameter, and if I just put it from P there, they'd intersect together on the minor axis, so that would have to be right. So just to clarify, I took half the major and swung from N. Now to get the and that gives me a point on the minor circle. So now I can put my compass here in the middle, and I can swing my minor circle. Now I can swing my major circle by bringing it out, the compass out to point J. So just to clarify again, if you're unsure, to get a point K, to get the point K and M, set your compass to half the major diameter and swing from the focal points. Okay, swing from the focal points, and where they intersect is a point on your circle, so you can put your point on your minor circle. So you can put your compass on the axis, move the circle to the point of intersection and swing it about. Now, we're going to divide our circle up into 60-30 now. So I'm just going to line up my 45-degree set square with my major axis. Okay, I'm going to slide it back. There we go. So I'm drawing the lines through this, the center. I can extend those too. Now that's then divided up into 60-30. Now just to clarify, if you're having a little trouble doing that, an alternative thing you can do is set your compass to the radius of the major circle, and from where the major axis and minor axis intersect the circle, look, you can swing backward, it hits it there, look, that gets you a point there, down there, and then from the minor axis you can do the same, and then you can join them through the circle. Okay, it's not as accurate as the set square. So look, you do just one arc there from the end of the minor axis, where it hits the major circle, you can join it right through. It's just worth knowing that, but it's not as accurate as the set squares. Alright, so now that we've divided up into 60-30, what we're going to do now is from where the big circle, or where the division lines, the major circle, so I'll label those circles. So major circle, major axis, minor circle, minor axis. Right, so where the division lines hit the major circle, we're going to go parallel to the minor axis towards the major. So we're going to go parallel there. That's a little bit inaccurate from me. Just fix that. Doesn't matter if they're slightly off, like I just like it in symmetry. Now, so towards the middle. So where the division lines are hitting the major circle, we're going to go parallel to the minor axis towards the middle. Now, where the division lines hit the minor circle, we're going to go parallel to the major axis away from the middle. Okay, so we've established our points on the ellipse. So we're going to freehand sketch them in. So we're keeping our hand inside the curve. And now I'm going to pause the video and sketch it all the way around. Now, so we've the ellipse sketched in. Okay, so there's not a lot to do left. The major thing is the line BT is a tangent to the ellipse at point T. We don't know where exactly the ellipse or the point T is on the ellipse yet. So that means it's a tangent from a point outside the curve. So what we're going to do is we're going to put our compass on B. And we're going to bring our nib to N, which is one of the focal points. So that's F1. So we're going to swing a circle with B as the center, and the radius of the circle is the distance between B and N, or B and the focal point 1. So we swung that compass there, center at B, and nib to N. Now we're going to set our compass to the major diameter. So the distance between L and J. So we're going to set our compass to. And we're going to put our compass on P, aka F2. We're going to swing a big arc there. Okay. Now, where that arc intersects the circle we've just drawn, we're going to join that back to P, or F2. Okay, now where that intersects the ellipse is the point of contact T. So that's the point of contact between the tangent and the ellipse. So now we're going to join B to T. So there's the tangent BT. There's the tangent BT. So we don't have a lot to do after that. We're going to we have to draw in this portion of the circle. Okay, this sectors of the circle. So we're going to set our compass to BT. There we go. And we're going to do that there as well. Okay, now we have to just draw in this design here. Alright, and it's the distance between here and there is 15, and they're joining back to P, and then those lines are 15 apart. Okay, for like the stitches on the rugby ball. So we're going to mark 15 along our major axis from the center and then we're going to mark up 15 and down 15. Now I'll zoom in here so we can see a bit better. So I'm going to lightly join this to P, lightly join this to N. So remember that point is 15 millimeters from the center. I'm going to lightly join N to the point 15 mil above the center and join it back to P. Now what I can do is go up here and heavy this in. This is parallel to the minor axis. This in. It's a good thing I stopped that there and checked that there, as that was the wrong dimension. I'd marked 15 and 10 as opposed to 15 and 15. And now we can do the seam, or the center of the rugby ball. We're basically heavy in the major axis here. Okay, and that is the question done. Alright, so we've clearly shown all points of construction and all points of contact. Cheers. Thank you. Bye bye.